Hey, welcome back everybody. This is Mr. Crawford. Today we're going to be discussing Integrated Math 3's Practice 3, the exponential functions and their graphs. At the beginning, I just want to make sure we all understand the concept between the base and the exponent. The big number that the exponent is attached to is known as the base. So the base in number 1 here is 2, whereas the x is an exponent or a power. Whenever the x, or the variable, is part of your exponent, you are now working with an exponential function. In the second one, the base is 2/3, and the exponent is x plus 1. In the third example at the top, the base is 3, and the exponent is 2x. And the reason it's important to distinguish between those is because on the next part, if the base is something greater than 1, as in 2 is a number greater than 1, or 3 is a number greater than 1, the graph of this is going to show something called exponential growth, where it starts off on the left-hand side just slightly above the x-axis, and then it turns when it gets to the right side and goes up sharply like this. It will actually never cross the x-axis. So anytime you see an exponential equation and the base is some number bigger than 1, like a 5 for example, it's going to show what's called exponential growth. Exponential growth. If the base, however, is something between 0 and 1, some kind of a fraction, like the second example was, where it was 2/3, these kind are going to show exponential decay. They look similar, but they start off high, moving left to right, then they go and flatten out right above the x-axis. So anytime your base is some kind of fraction or a decimal between 0 and 1, that's going to produce a graph of exponential decay. Let's see an example of that. Down at the bottom, I have a table of values. The exponential function we're going to use is y equals 2 to the power of x. I'm going to take each one of these x's, plug them in for x, and find out what my corresponding y value would be. So when I plug in -1, I get 2 to the power of -1. And negative exponents, if you're not familiar with the exponent laws, have to go to the bottom of a fraction and turn positive. So I put a 1 at the top of that fraction, I take this 2 to the -1, put it at the bottom, turn it into +1, and now I just ask myself, well, what is 2 to the +1 power? Well, that's 2. So I end up with 1/2, or 1/2. When I plug in 0, another exponent law, anything to the power of 0 is just the number 1. When I plug in 1 for x, y equals 2 to the first power. 2 to the first power is just 2. When I plug in 2 for x, y equals 2 to the second power. 2 to the second power is 4. So now I have these 4 ordered pairs that I'm going to place on the graph over here. I have -1 and 1/2, which would be about right here. -1 is 1 to the left and then up a half. I have 0, 1, which is up 1. I've got 1, 2, which is right 1, up 2. And I've got 2, 4, which is here. So you can see this exponential growth shape taking place. Flip to the back side. Similar situation. This time, however, the base is one of those fractions. It is a number between 0 and 1. So by the time we're done graphing this, this should show exponential decay. I'm going to plug in -2 for x. What is 1/2 to the -2 power? Again, you would have to move this entire fraction to the bottom of a fraction to change this to positive. When you're done with all that, you'll actually find out this makes the number 4. Plug it in -1, 1/2 to the -1 power, ends up being the number 2. When I plug in 0, 1/2 to the power of 0, anything to the power of 0 is just 1. When I plug in 1, 1/2 to the power of 1 is itself 1/2. And when I plug in 2, 1/2 to the power of 2 is 1/4. You might notice that over here in the y column, these numbers are halving themselves, or dividing by 2 every single time, right? Half, as in the base. So it starts off with -2, +4, that's left 2, up 4. Then we got -1, +2. We have 0, 1. We have 1 and 1/2. and then 2 1/4, you can see it's getting closer and closer to x, but it will actually never cross x. And so this graph is showing exponential decay. Like so. Down here, just wanted to see if you can take any specific f function value, plug it in for x, and find out the answer. So for example, f of 3 in this function would mean for us to replace this x with the number 3, which would then say 4 to the third power. 4 to the third power actually makes the number 64 because it's 4 times 4 times 4 when you raise something to the third power, and that makes 64. So that's kind of the idea for this section down here. Let's see if I can fold this up. Okay. For 1, 2, and 3, if I wanted to find f of 100 in this function, I would have to plug 100 in for x. And I would end up with 4 times 100 minus 12, and that makes 388. When I plug in negative 3 in number 2, I get 0.5 to the negative 3 power. Right? That actually ends up making the number 8. If you don't believe me, you can check on a calculator. It should be very helpful in this situation. Plugging in f of 2 into number 3, I'd get 2 times 2 to the power of 3 plus 1. A common mistake here is people want to distribute that 2 and then raise it to the power of 3. They think 2 times 2 is 4, and then they do 4 to the third power and get 64. That's not true. If you multiply before doing exponents, you're breaking order of operations. So this 2 just has to wait his turn. First, we have to do 2 to the third power, and 2 to the third power makes 8. 2 times 8 is 16, and 16 plus 1 is 17. Number 4, we're looking for g of 6 in this quadratic function. There are 2 different places to plug in for this one. There's an x here and an x here, so I'm going to get 6 squared minus 4 times 6 minus 5. 6 squared is 36. Negative 4 times 6 is negative 24, and then minus 5. 36 minus 24 is 12. 12 minus 5 is 7. Number 5, plugging in 4 for this x. 4 plus 1 would make 5, so I end up with negative 2 to the power of 5. Negative 2 to the power of 5 makes negative 32. Plugging in 3 for number 6, I would get 2 minus 3 plus 3 to the 4th power. 3 to the 4th power, if you're not aware, would be 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I end up with 2 minus 3, which is negative 1, plus 81. That ends up just being the number 80. Number 7, I'm going to plug in negative 2 here. Negative 2 to the power of 3 is negative 8, and negative 8 plus 4 makes negative 4. Plugging in 32 into this function, I'd have 1/8 times 32 plus 10. 1/8 times 32 actually makes the number 4, and 4 plus 10 makes 14. Last one, number 9, if I plug in 10, I got 2 places in this fraction, top and bottom. It would say 10 minus 4 over 10 plus 2. 10 minus 4 is 6. 10 plus 2 is 12, so I get 6 out of 12. Better known if we reduce the fraction as 1/2. 1/2 for that. All right, hope that helps. Watch this video as many times as you need to, and I'll catch you next class.